What if I told you we can travel beyond the speed of light without breaking Einstein's laws of physics? The Alcubierre drive, proposed by Miguel Alcubierre, is a theoretical concept for us to break the universe's speed limit, but not the laws that set it up. But first, we need to understand how fast humanity has managed to go, starting with something some of you might have already traveled with: airplanes. Airplanes can go at around 900 kilometers an hour, but that is nowhere close to the speed of light. So, we need to head out to space where there is no air resistance pushing our craft back. Going past the ISS orbiting Earth at around 28,000 kilometers an hour, we find the Voyager 1, a spacecraft set to head out in deep space, flying at 61,000 kilometers an hour. However, in 1957, a massive underground explosion has led a manhole cover to fly at 240,000 kilometers an hour. But even that is a mere 0.02% the speed of light. If we want to even go close to the speed of light, we need to go faster. Going back on Earth, humans have built a particle accelerator, particles being slammed into each other at over 99% the speed of light to create antimatter. But as we get faster and faster, it appears that we cannot go beyond the speed at which light travels. Is the speed of light really the fastest we can go? Is it really the universal speed limit? Unless we don't move the spacecraft through space, but let space move the spacecraft. Enter the Alcubierre drive. The Alcubierre drive, proposed in 1994 by Miguel Alcubierre, is a warp drive idea in which we are not moving the spacecraft through space, but by using negative mass achieved by quote-unquote exotic matter, push and pull the space around our ship, creating some sort of a warp bubble around our craft. And that is one of the very few ideas that let us go faster than light without breaking Einstein's laws of physics. On paper, that sounds pretty simple. We move the space around our spacecraft, and therefore we are quote unquote moving faster than the speed of light. Well, there is a huge problem with the Alcubierre drive. The exotic matter that this idea relies on is only theoretically true, and we have no idea if it actually exists. But don't give your hopes up. The Casimir effect, named after Henry Casimir in 1948, suggests that we can create a similar effect to exotic matter. According to quantum field theory, empty space isn't really empty, but it is full of virtual particles. So if you place two perfectly flat, neutral metal plates super close together in a vacuum, you restrict how many particles may exist between them. So since more vertical particles exist outside this gap, pushing them together creates a region of negative energy density, proving that, in theory, the properties of exotic matter isn't impossible. Another huge flaw that the Alcubierre drive has is its energy consumption. Early proposals of the Alcubierre drive claimed that creating such a warp bubble would require more energy than there is in the entire observable universe. However, newer estimates are more generous with that number, taking roughly the mass of a small vehicle converted entirely into energy using E equals mc squared. Now, while this is just a theoretical concept and we don't know for sure how practical it is still fascinating to look at how we can travel across the universe, proving how humanity doesn't give up on their imagination. It tells us that we are determined to set a goal that we can achieve together, even if it means going beyond the speed of light. This was the Alcubierre Drive explained. Thank you guys for watching, and I'll see you next time.